Okay, so in the previous video, you saw the demo of the RAG engine using Pinecone and LangChain. Here we'll do a brief overview of the tech behind this RAG engine. So this RAG engine is hosted on Streamlit, and it is, as I mentioned, it's based on LangChain. Uh, so we have used LangChain as the platform to split and vectorize the files. So let's come to the important functions. Okay, so process documents. Here is where we start uploading the documents, and the documents are then split based on the character text splitter from LangChain, which splits it, and after the split we get the embeddings on Pinecone, which is fairly straightforward. It does the it first creates the index if it doesn't exist, and then using the OpenAI embeddings, it vectorizes these chunks, and then we can go back to the that's it about the vectorization and storing of the vector DB in Pinecone. At query time, we will basically go to the query LLM function. Query LLM, yes. Here we have constructed a LangChain chain which uses GPT-4o, and we also feed in the session state of the earlier messages for context. And what happens is, what I wanted to show you is that we first, as a true RAG engine, we first before actually querying the LLM, we first query the Pinecone vector DB to get the relevant chunks. And let me just show you where that code is residing. Yes. Yes, so once we go into query LLM, it uses the retriever. Okay, yeah, so the retriever automatically fetches the chunks from based on the query. So we have passed it in the query here as well, as to this chain. So internally, behind the scenes, what this retriever does is that it fetches the relevant chunks and then feeds them into the chain, and then it attempts to answer the query. In the previous version, I had also written the full logic behind the chunking and sort of the retrieval, and adding it to the context of the LLM. Let's see if we have here that code as well. Yeah, so here I have written this context to get the to query the Pinecone index. From there, get the relevant chunks and join them together and feed them into the prompt window, the context window of the LLM, and get the answer from that. But as we can see, LangChain has made that very easy by giving us a retriever function which does all of that behind the scenes. This, as I was mentioning, the web functionality is enabled by Streamlit, which is hosted on Amazon and AWS, and let's take a quick look at that. That's fairly straightforward. We have the server running on AWS in a container, where we just upload, we sort of git clone this repository, and from here it just runs out of the box. So yeah, that's the brief overview of the tech behind this platform.